Hello, folks. This is Mr. Walker here, coming to you hot and ready for our next round of notes. So, we are going to be talking about today our friend the kite and our friend the trapezoid. So, first, let's remember what a kite is. A kite is a four-sided shape that has two adjacent congruent pairs of sides. So that means that the sides that look the same in your shape are the same. So up top, even before we jump in, BA and BC, they both are going to be adjacent to each other. They are congruent. Down here, DA and DC are next to each other and also congruent. You can also eyeball this type of shape because I'm going to give you ahead of time that context that it's a kite. So if it's a kite, it's fine for us to assume this. All right, let's get into some more details of the kite. So if a quadrilateral is a kite, then its diagonals are perpendicular. Remember what perpendicular means? That means that they meet and cross together and they make a 90-degree angle. So remember that for the future when this stuff pops up. Next thing we got, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Now, that may sound confusing because we got about two pairs here that we could look at, but how do we finesse this out? When we look at these sides here, we can clearly see some things. BA and BC are the same size, and DA and DC are the same size. When we want to look at these angles, if we have angles with the same kind of sides for them, that means that they'll most likely be congruent to each other. So, if I looked at angle B and angle D compared to angle A and angle C, we're going to notice some changes. So, let's look at the first thing. First theorem states that these two lines here, AC and BD, they meet at a right angle. So all of these angles inside of here, they're all 90 degrees. Let's put a couple more boxes. Boom. Next thing we got going on. They tell me that if quadrilateral ABCD is a kite and BA is congruent to BC, then angle A is congruent to angle C, and angle B is not congruent to angle D. Remember, these two angles here, A and C, they have the same kind of sides. This bottom side here from angle A matches up with the bottom side from angle C. And this top side from angle C matches up with this top side from angle A. So, because those sides are going to be meeting at corners and they're the same size, we're going to take that theorem to say that these guys will be the ones that are congruent, not the ones that have obviously different sides with B and D. So, those are our theorems for kites. Things to remember one more time. The angles are in between the sides of different length. That's a nice little cheat sheet for us. All right, next thing we got, we're going to be talking about our friend the trapezoid. So let's get into the trap. Our trapezoid, if it is a trapezoid, is isosceles. Remember what isosceles means? It means that you have two sides that are the same. This lets me know that each pair of base angles are congruent. So when we're talking about base angles, we're talking about on the sides that are parallel. So a trapezoid has one pair of parallel sides. I could assume it's these two right here. Because if I extended these two sides here, AB and DC, eventually they would end up touching each other somewhere up here if I extended them off. So I could tell that those two sides, they are the bases. And these guys here are our legs. And because it's isosceles, these guys are the same. These two, obviously not, but they are parallel. Now, jumping into our next thing. If a trapezoid has a pair of congruent base angles, then it is a isosceles trapezoid. I had to get that Mathanese in there. So, if you have an isosceles triangle, Sorry, not isosceles triangle. I'm getting mixed up on my shapes. If we have an isosceles trapezoid, then the base angles are congruent. If we see congruent base angles, the trapezoid is isosceles. All right, final theorem we got here for the regular version of the trapezoid. A trapezoid is isosceles if and only if its diagonals are congruent. So this is another little thing that'll help us know if these things are isosceles. So if trapezoid ABCD is isosceles, it has the following things. That lets me know that these two sides here are the same and that these angles A and D match up with each other and they're congruent. And up top, B and C, I'm going to go ahead and mark those just in case. Those two are also going to be congruent. Now, if the reverse is also going to be true, so if we see these angles are congruent, the trapezoid is isosceles. And then finally, if these two diagonal lines from B to D and from C to A are congruent, that means that this is isosceles as well. All right, final theorem we got here is specific to the midsegment of this trapezoid. Now, we've talked about midsegments one time in the past with the midsegment of a triangle, so it's been a minute since we've seen this. So, the midsegment of a trapezoid is parallel to each base, and its length is half the sum of these lengths of the bases. So when we're talking about the midsegment, we're talking about this segment right here in the middle from E to F. So if E to F is the midsegment of this trapezoid, then BC, the top, is parallel to EF, our midsegment. And EF, once again, is parallel to that bottom segment, A to D, as well as EF is half the sum of BC and AD. All right, now that's quite a few bits of work that we had to go through to take a look at. Now, we got some practice here. So, let's take a look at some things. Go ahead and pause it, come on back, and we'll see what we got going on. All right, folks, hopefully you went through and paused it. Let's go through and take a look at some information. All right, first thing they tell me, this shape here, QRST, is a kite, and they want me to find the values of X and Y. So, first off, if I look at this kite, QR and QT are bigger than over here, RS and TS. So that means that these two are congruent, and these two sides here are congruent. Now, along with these being congruent, let's remember some other information from our theorems, okay? So let's hop back over on there. Our first theorem for the kite said, if a quadrilateral is a kite, then the diagonals are perpendicular. That means they meet at a right angle. The second thing we have is that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. They're in between the two sides. So let's go through and handle some of this math here. I know that this angle over here by R and this angle over here by T are congruent. I also know that these lines from Q to S and from R to T make a set of perpendicular lines. Remember, perpendicular means that these guys add up to 90. So that means that X already is a 90-degree angle. Let's make that look like more of an X. Now, because we know that X is a 90-degree angle, I need to now start working on figuring out what this is. So let's talk about what these two things are. I know that this angle here and this angle here are both congruent. So let's figure out what this one is over here, because it's going to match up with this one over here. Inside of this shape, we got one of our old school friends from way back in the day at the beginning of the year, and it is a triangle. So how do we find out stuff inside of a triangle with its angles? We always take our good friend 180 and we're going to subtract those two from 180. So we got 180 minus 90 minus 25. 180 minus 90 is 90. 90 minus 25 gets me 65. So that means that our two angles are x is 90 and y will be 65. Nice and easy for us. Okay, next thing we got going on here. It says LMNO is an isosceles trapezoid. They want us to find the value of x. Now, if this is an isosceles triangle, let's look at the lines that they gave me here. They gave me NO, not NO, NL, this diagonal line, and MO. Because these two are diagonals here, I know that NL is congruent to MO. So let's set these guys equal to each other and start to solve. I need to go through and get my x from one side to the other and my constants to the other side. So if I subtract this x over here, that makes 1x. If I add these 3's over here to this 1, that means that my x value is 4. Okie dokie. Nice and easy. Now, we got another kite here, and they're wanting us to find the values of x and y, their angles. So let's note some things. These two sides here, from AB and from CB, these are the same size. I can tell that because it's a kite, remember. And then down here, these guys here, oops, sorry about that. These guys down here at the bottom, from A to D and from C to D, are also congruent. So, if these guys are congruent down here and these ones are up here, that means that this angle here from A and this angle over here at C are the same. So, that means that x is equal to 111. But how do I find y? Remember what all these four angles add up to for a quadrilateral. They add up to 360. So, for me to find y, I'm going to subtract the other angles we have in here. We got 88 minus 111 and minus another 111. And that will give us what y is. So when I do that, I got 111, 111, that's 222 plus 88. That gets me a lot of stuff. This is about 310, I believe. Yep, 310. So when I do that subtraction, that tells me that y is going to be 50 and x is 111. All right. Next thing, we got an isosceles trapezoid. So let's get into the trap. Let's go through and deal with some stuff. I know that in an isosceles triangle, not triangle, trapezoid. Sorry about that, folks. In an isosceles trapezoid, the base angles here are congruent. So that means I can set these guys equal to each other. Nice and easy. So I got 3x plus 15 is equal to 60. When I do that, I got to get x by itself. So let's bring that 15 over. That's going to give me 3x is equal to 45. And when I divide both sides by 45, I end up with 15 is equal to x. Nice and easy. All right, home stretch, people. We got some challenging questions. First thing they tell us, the perimeter of a kite is 66 inches. One length is going to be 3 less than twice the length of another. So, that sounds like a lot. One length is equal to 2 times 3 less than that other length. So, do we know what one length is? The length of one side, we don't know what it is yet, but it's x. So this is going to be 3 less than twice the length of the other. 3 less is minus 3. And twice that length is 2 times x. So let's go through and find these answers here. Here's our perimeter here. We got x plus x, because there's two sides that are the same, plus 2x minus 3 plus 2x minus 3 is going to equal 66. We combine our like terms. We got four different x's, x, x, and 2x and 2x. That gets me 6x, and the other ones give me a negative 6. I take that 6 and I add it over to the other side. It gives me 72. And then I divide both sides by 6, and that gets me that x is 12. If x is 12, that lets me know that two of the sides are 12. So in our kite, we got two sides that are 12. And then for the bottom sides, we got to go through and plug it back in. So let's plug it back in. We got 2 times 12 minus 3. 2 times 12 is 24, and 24 minus 3 gets me 21, and that is our other two sides. So we got 21 and 21. Okay. Next one we got a trapezoid, and they gave us the mid segment for these two. So let's go through and deal with an easy one. They want me to find the value of x. Our x is this bottom side here. So let's find it. Since 19, this is our mid segment in the middle. I know to get that, I took the top base and that bottom base and added them together and divided by 2 to get 19. So I got to take that 2. I got to multiply it to both sides. That's going to give me 3, not 3, 38. And then I got 13 plus x is equal to 38. I subtract that 13 from both sides. That gives me that x is 25. Same type of deal is going to happen for our next one. They gave me a mid segment and a little bit more algebra for his. So we got our bases added together. 23 plus 11x plus 2 is equal to 29. I got to deal with that too, the same way I did with the last one. So I'm going to multiply it to the other side, giving me 58. And then when I combine my like terms, I got 25. So I got 11x plus 25 is equal to 58. I subtract the 25 over, that's going to give me a 33. And when I divide both sides by 11, I get a 3. All right, folks, you were saved by the bell. I appreciate y'all working with me. Have a good rest of your day. See ya.